Okay, so let me just repeat this a little bit for the recording. Okay, sorry about that. So this is what we went through last time, right? Last session with infix, prefix, and postfix notations for expressions. And as we have learned in school, right, since first grade or second grade, basically when you start doing math at school, in school, we learn the infix notation for writing expressions, right? Writing formula. And so you got operator in the middle. That's called infix. But with infix, you still have these precedence rules. You have to follow these rules to do your expression, right? To evaluate an expression. First, you have to do the parentheses. Everything that's inside of parentheses, you do that first. After that, you do exponentials. After that, you do multiplication and division, and after that, it's addition and subtraction, right? With prefix and postfix expressions, you don't have any of these precedence rules, right? You just do operator and its operand, right? With prefix, operator always comes first. The postfix, operator comes last, right? And then that's what we do for the review. And so for this expression to convert the infix to postfix, right? What we do is first of all, there's a multiplication in here, right? When we write this expression like this, a times b plus c in parentheses, we can omit the multiplication sign, but it's there. So first, right, follow the infix rules. We're going to do this first, right? Parentheses first, and then parentheses, right? And then we do multiplication, and then we do division. That's it, right? So when we write down all the operands, first we're going to do multiplication, right? The multiplication happens for b plus d, right? For b and d. So the plus goes there, right? Postfix means the operator always work on the operand right before it, right? And then second is c minus e. And so for that, put the minus sign after the c and e, right? That's called postfix. And then you have to consider that these are BD plus. This is one item now, right? In this expression. And so when after that happened, a times a multiplies the result of b plus d, right? So after b plus d, you do the multiplication of a multiplies the result of b plus d, right? And then the last thing is the division. Everybody got that right? Cool. Now the next one is this big expression, right? Hello? Okay, this is that expression, right? And this is prefix, remember now, right? So for prefix, we look at this expression. What are the items we can do immediately, right? 1, 2, 3, 4. So there's these two with this, right? These two with this. This is the greatest common factor. The greatest common factor between 12 and 18 is 6, right? And then the least common multiplier, multiple, which would be basically 2 times 3, right? Because these two are not, they don't share any common factor. So that's 6. And now between 6 and 8, the common factor is 2. Right? And here also 3. And after that, this is the expression we got now, right? Right? And so now you look at this, you got operands and an operator. So that's one you can do, and that's a second one, second operation you can do, right? And so that becomes 6 times 6 is 36. 2 to the power of 2 is 4. Right? So now this is what we got. Exponential division 6, 4, and 3. Right? And this is division, right? 36 divided by 4 is 9. Right? And then there's the 3. And we got exponential, right? 9 to the power of 3 is 729. Anybody has a question about this? Any question? No? Okay, good. So this is the what we went through last time, right? The expressions and all that stuff. And there are more questions like this. And if you want to go to the I don't see anybody coming to the meeting. Oh, yeah. Oh, sorry, I don't see them up here, but. And this. Okay. Okay. Sorry about that. I wasn't watching the screen here. Technical. All right. Sorry about that. Share my screen here. Okay. So I apologize. We'll go and where else is online? So we went through these two practice problems. I guess when you've get some time, try to do some of these practices. Also, let's see. What I want to show you is the wiki, right? In their wiki site, they have some of these problems in there. Over here. And also, okay, they have some videos on YouTube. So if you want to go on your own pace and review some of this material, this is where you want to go. Okay. Again, it's ACSL.org. This is their wiki, so just go on there or just go Google for ACSL wiki, I guess. You'll find it. Right. That's where you'll find it. You'll find these topics. These are all the topics that ACSL would touch. Not everything is for you guys don't need to go through everything right now, but for the ones who are going to high school, right, if you're participating in the senior division, then you will have to go through everything. For the juniors, list is not needed, is not computed on. What else? Data structure. The data structure? No, it's the finite state machines and finite state automatons, and regular expressions. Those are not needed. Okay. Everything else is I think is there in junior. So so there you can go get some exercise, do some practices, exercise, and find out more about ACSL. So this is our review of the last time's material, and continue on. This week we're going to talk about recursive functions. All right. So first, we'll talk about what is recursive. What does recursive mean, right? By definition, there's this word is used in a couple of different situations, right? So in math and linguistics, it basically says relating or involving a repeated application of a rule, or produce to successive results. So like in linguistics, grammar a lot of times is recursive, because in a lot of language studies, you have to define a term using some other grammatical term, right? So there's self-referencing type of situation there. in computing, it's a program or a routine or function, what we're talking about here, of which a part requires the application of the whole or part so that it explicit interpretation requires in general many successive executions. So it's basically, there's a self referencing part in there. So recursive functions in the ACSL's definition is basically this. An object, when you say it's recursive, it basically defines, it is defined in terms of itself, right? And when we talk about functions or subroutine, it's basically a function that calls itself, right? In pretty much all languages, all computer languages allow that, right? The function can call a function itself. So this is a fundamental paradigm in programming. You write any kind of program, you probably will encounter recursive function, here or there, right? And then there's also indirect recursion. That means when the function doesn't directly call itself, but it calls something else, and that function calls something else, but eventually something else calls the original function, right? There's a circle in there. That is also a type of recursion, indirect recursion, right? So I guess everybody knows this Fibonacci numbers, right? Have you guys all learned this in school? Okay, so this series of numbers in the Fibonacci series is, you start with 0, 1, right? And then the next number is the previous two numbers, right? The sum of the previous two numbers. And so the third number is 1, right? 0 plus 1 is 1. And the fourth number is 1 plus 1 equals 2. And the next number is 1 plus 2 is 3, right? This makes up a whole series that goes, to infinity. But for any number, right, the result of this function, right, the Fibonacci function, is the sum, the addition of the previous two numbers, right? Right. And then for the, every number is the same, right? You basically repeat this pattern. And when we write that into a Python implementation, for example, that's it, right? So this simple function can give you any, the Fibonacci number in any of its positions in that whole series, right? So if you say Fibonacci 100, it'll give you the number in the 100th position in that whole series, right? That's how recursive function works, right? It basically, you define this function, it takes a parameter, an integer. If it's less than 2, so if it's 1 or 0, right, that's the result is that number itself. And any number that's greater or equal to 2, it is the previous two Fibonacci numbers add together, right? The sum of the previous two numbers. So this is called recursive, right? It calls this function again inside itself, right? And it calls it twice. That doesn't matter, but the recursiveness is this, right? Inside this function, it calls itself. But one thing you have to, this number always decreases in this function, right? So there's a guarantee that this function, this recursion will end somehow, right? Otherwise, you'll get into, I mean, the program will just get into an endless loop. It will just, it will kill the program in the end, because right, by nature of computer programs run, when a function is called, something is put into computer memory to record that state, right? Because you have to return to a previous call of the function somehow. So eventually, if the function, if the recursion doesn't end, then you'll fill up the whole computer with junk, right? And eventually, everything will just die. So the other, I guess everybody probably have learned this, which is factorial, right? Factorial is basically, if you have a number, it's the multiplication of that number and all the way down to 1, right? So you can see that this in this function, the factor of 0 is 1, right? And then the factor of n is basically n times the factor of the previous number, right? So there's a recursion right there, right? So if it is 0, the result is 1. Otherwise, it is this number multiply the previous number's factor. Right? This is the most simplest, I guess the simplest form of recursive functions, right? And in the wiki, they have a number of other problems like this, right? So this is also a recursive function, right? Basically, it defines this function by using itself, right? So this function says if the parameter, if x is greater or equal to 4, the function result is the x minus 1's result of that function plus x, right? Otherwise, it's 2 times x, right? And so now, can you guys find F6? Find the result of F6? For the ones on Zoom, please do the same thing and send me the result in the in chat.
What does he mean by that? Does he multiply x by 2?
Yeah. 2 times x. That's
Would you entitled to assign to what? Assign yes, or
the result is yeah.
the result of what?
It should be written as that, right? I guess I copied. You're right. This should be written like this, right? Okay, all done. So basically, what we do is we put x in place, right? When we evaluate x, x is greater, 6 is greater than 4 right now. So F6
Here's what I found.
equals F5, right? That's x minus 1 plus 6, right? Plus x. And next, we got to evaluate F5, right? Because we don't have that yet. F5 is F4 plus 5, following number 1, right? And then next, 4 is still, greater or equal to 4, so it's F3 plus 4, right? And then 3, when we evaluate F3, the x is 3 now, which is less than 4. So F3 is 2 times 3, which is 6. So now we put these values back up here, right? 6 plus 4 is 10. And 10 plus 5 is 15. Right? 15 plus 6 is 21. Right? That's how you, when you run, when you participate in the contest, that's how you have to evaluate it. Right? If we were to, do this in Python, right? Then we can, define this function in terms of its definition, right? I like to, write as little as possible. So I, turn this to, I evaluate x against 4, right? First, if it's smaller than 4, basically number 2, right? I'll return 2x, right? And otherwise, I'll return the recursive call this function again with x minus 1 and then plus x, right? And in Python, you also have this what do you call it? Conditional expression, right? So if x is smaller than 4, then this parenthesis, right, this expression is x. Otherwise, it's f. Call this function again with x minus 1. Right. So these two functions generate the same result. Let me see. I think I still have that. In here. So this is what I had that function defined, right? This is f01x. This is basically that function, and the function in other definition, right? In the other implementation, it will return the same result. Now, the problem 2. Let's evaluate that. Okay, that's 3 minutes. In real contest, you have 5 minutes to resolve the whole thing. So there's the whole sequence, right? So first you put X and Y in place. And because, right, this is greater than 0 and it's odd, X is odd, so it is Y minus 2, X minus the function of Y minus 2 and X minus 1. So follow this, right? Eventually we got to this 0, and then we put the 0 we put here, we got the minus 5 here, right? F05. 0, 5 is X minus Y, which is minus 5, negative 5. And then we put it back, and we end up with that result. Again, if we write this out in Python, right, this is how we would implement that. If it is equal or less than 0, we return that. Otherwise, if it is an even number, right, after this statement, X is guaranteed to be greater than 0, right? After the first if statement, right? X is guaranteed to be greater than 0. So we just check if it is a even number, then we return that. Otherwise, we return that expression. Again, these are recursive function calls to the function itself, right? And yeah, I guess we have that here as well, which is F2, 7, 4. That's the result. So these are, simple demonstrations of recursive functions. In the contest, the most important things are, it will give you stuff like this. Okay, give you, the definition of this recursive function in terms of itself, right? And then you have to, be careful with the evaluation, which is, every step, you have to put the parameters into the right place and then arrive at the right result, right? Because sometimes it's kind of, it's easy to get these things wrong, right? That's all. So these are some fun references of the use of recursive function. Okay, this is a, there's some references here in Wikipedia, and fractals is a kind of interesting use of, these are all recursive functions of very simple form. Okay, very simple formats, and then you get these incredible graphics out of those. Here's a, it shows this. This is a, I guess this is this Mandelbrot set, and you can see that this, this is a pattern that shows up in a lot of places. Okay, and in this fact, in this set itself, you can see that the pattern repeat itself, because these are data sets of unlimited numbers, right? So this is a simple function that generates all these numbers, and then these numbers are plotted on a two-dimensional surface, right, with x and y, and if you zoom into this graph that this formula generates, and you can see that a lot of times you can see those patterns repeat itself, basically endlessly. And also, if you're interested, there are a lot of people studying this Mandelbrot set. In there you can actually find the like the Fibonacci series of numbers in this whole thing. Okay, and then there, if you go on to college and for example, you can probably learn more about these things, right? These are fractal art that lot of these are basically generated with simple math formula, you know, to produce all these graphics, right? And you can see that Mandelbrot set shows up in a lot of places, and not just in the Mandelbrot set itself, but in other data sets where you can see this pattern showing up in there. So these are what we have for recursive functions. Okay. And there are some more references in the wiki from ACSL. Again, these are things on YouTube, so you can go and watch on your own. So this basically talks about the concepts as we discussed in here. Oh, well, I guess. Any questions about that? In this one, actually, it talks about a lot of the fractal functions that will generate patterns like this, right? Let's see if we can. What is this? Okay, so this again is a very simple math formula. It basically it generates a triangle, and then it replaces every edge with 1/3 of it with another triangle, and just repeat that whole pattern. And this too, basically a very simple formula that generates something like a tree, right? So these are the more fun facts about recursive functions. That's all we have for this topic. Any questions? Okay. If not, then we can take a look at the problems in the wiki site. Basically, this gives us the this gives us a way to understand what you will encounter, right, in these in the ACSL contests, right? So with it's basically the same kind of problem we just went through, right? It's gx is a function, and if x is greater than 0, it's defined one way, or otherwise it's defined another way, right? This is how your ACSL junior contest looks like in this particular topic. This will show up in the first contest and you will have two problems like this, right? Or similar to this. So I guess this is everything we have for this topic. If there's no more questions, we are pretty much done today.
Really?
Yep.
So we can go home?
We can go home, or we can do a test if you want to. Let me see. A test would be
We haven't had.
uh,
Whoa.
let me see what this. Okay, let's do these two problems. Two problems on the screen there. Go ahead. Yeah, we should take a break. Sorry about that.
I gotta go.
I think somehow this thing, I have to download it. I guess, give me a second. Okay.
Stop touching my. That.
What? On that?
Holy shit. Are you on guest account or?
I thought you were pro.
Bro, I used to play that game all the time. Bro, you suck. You suck. How do you have 20 KKR? Holy shit.
Yeah, bro, I'm pro.
Bring mine.
Bro, when did you join? Oh, damn, OG. I'm also. Bro, imagine this. Actual skill. Yeah, actually have a skill. This map is still in the game.
This one looks
Is Kanji still in the game? Look at actually all in the game. Kroger?
He was not.
Cody.
He was
Let's play money level.
Yeah, that one is
We were playing around. We play like a money level game. Roblox.
Yeah, I know. That's like the study.
Such
Yeah.
a good use case.
It's kind of just like person function.
What would you just say?
I
I know that's a really long word for you, but I hope I.
So what you want your computer?
Oh my God.
You know what they do on Discord? That's why you have mobile data about. That's why you can talk about.
Minecraft, you know.
What is it?
Minecraft.
I thought I added you.
It's 30 is on here. I'm pretty sure. Don't think they're working. Single time is that.
Nerd.
Use Discord.
Wood.
What melee is that?
Discord is for nerds.
Do you have any contraband?
Shut up.
No, I know.
He absolutely does. Yeah.
What?
109.
Oh, damn.
Four.
Yeah.
You're weak. Sorry. No offense.
4. No, my God. 4.
Oh my god. Oh my god. Leave me alone. You guys are weird. I just want to do my dailies. Leave me alone.
Any body part, you get erection.
Whoa there. Or you guys laugh so hard you move the table.
You laughed at you. Weren't you that like, profile picture of that thing we're on?
What's your username
Wow.
You're gonna get erection.
You say eruption?
Eruption. Having a wet dream.
Can you access it? What's illegal about having a wet dream?
You're having wet dreams.
Yeah, that is.
Why? Why do
Bro, why?
Why? Because, yes.
What the password is what's the difference between A for the option?
My password is over there.
Your
ads are basically like women with the big.
Are you done?
What?
How about G2 as well? These are the questions for
You guys are gonna be
contest
on those lists on
for
websites.
junior contest one.
On those lists.
What?
Oh my god. Okay, I'm glad you're.
Yeah, I want to,
You're glad?
You glad?
Cause you know those other types.
okay, you guys can get started.
One legit.
Oh, yeah, somebody got a girl.
Let's see your character.
Let's do all these 4 questions,
You got a record.
all 4 questions, and then I want to collect them.
There's like Kiki.
Oh, it is fine.
All right, hey, guys, let's get started.
Smash.
Do all these, all 4 questions, all 4. Finish all 4 questions, and then I want them to be handed in. Put your name down. Don't forget to put your name down.
I'm trying to joke.
Excuse me.
Good strategy.